In this video, we're going to talk about our first transformation, which is a translation. So, for number one, we're going to translate the quadrilateral and label the transformed image using the prime notation. And then we want to record the coordinates of both quadrilaterals in the table to the right. So I've already recorded for the pre-image, so WIBL, and then we're going to record the image as well. So translating, if I'm translating up to, that means I just take this point and I translate or slide up to. So that would be I prime, W prime, L prime, and B prime. I took every point and I translated it up to. And then I take my ruler and let's just draw this so we can see. And there we go. Okay. So we've translated all of them. Let's go ahead and record the coordinates now. So W prime is now going to be 0, 5. I prime ends up being -2, 4. If I look at those ordered pairs, B prime ends up being -2, oh, you know what, that wasn't -4 before. That was -3. My mistake. Alright, so now it is -2, -1. L used to be 3, -2. Now it's 3, 0. Alright, so we've done what it has told us to do. The next question is trace the quadrilateral using tracing paper and use a tracing paper to determine whether or not the translation is an isometry. So let's first trace this using tracing paper. Oh, that pencil. That can do. Alright, so tracing using tracing paper. And it wants us to figure out whether or not that this is a translation is an isometry. And remember, if we go back to our notes from the previous video, an isometry is a transformation that preserves length and angle measures. Meaning, this length, after I translate, cannot change if it's an isometry. And this angle measure right there cannot change either. Now, we could use a protractor to actually measure the angle measures, but if we use tracing paper, if we line everything up properly, then we'll know that side length and angle measure was preserved. So as I translate it up, I see that that shape stays exactly the same. These lengths are the same. Those angle measures are the same. So by using tracing paper, I can determine that a translation is an isometry. And whenever I give an explanation like that, I always want to look back at the definition. And so we use the definition in the explanation. So translation is an isometry because it preserves side length and angle measure. The next part asks us, can you think of another way besides using tracing paper to show whether or not side length is preserved during a translation? Well, to show that it's preserved, I have to show that it has not changed. So one way to do that is to take a ruler and I can measure. So BL looks like that's 3 centimeters. B prime, L prime is still 3 centimeters. And I can do that for all of these. But let's say I don't have a ruler. What is another way? Well, in order to find the length, if I can think back to when we did Pythagorean theorem, if I wanted to find this length here, I could draw in a right triangle, and I know that this length is 3, this length is 1, 2, 3, 4, 5. I could find W prime and L prime there, and I can do that for this triangle as well. This is 3 and this is 5, and so let's show what that work would look like. To show what that work would look like, I would have that 3 squared plus 5 squared equals W prime L prime squared. Well, 3 squared is 9. 9 plus 25 is 34. So the square root of that will equal W prime L prime. And if I use the Pythagorean theorem on this other triangle with W and L, I have again 3 squared plus 5 squared equals WL squared. Remember, WL without the bar above it means the length of that segment. And so then if I solve this, I end up getting that the square root of 34 is equal to WL. And so if they're both equal to square root of 34, then I can state that W prime L prime is equal to WL. And if their lengths are equal, then that means that those segments are congruent. And then I can do that for all the rest of these. For the vertical segments, I can just count those 1, 2, 3, 4, 5. So I know that IB is equal to 5 and I prime B prime is equal to 5. And so IB must be equal to I prime B prime. In other words, segment IB is congruent to segment I prime B prime. And you could do that for all the rest of the segments as well. So Pythagorean theorem allows us to also find the side lengths and prove that those are equal. So we can do that in order to prove that it is an isometry. In the next part, it's saying examine the coordinates to determine a pattern of how the coordinates change from W to W prime, I to I prime, etc. Explain this pattern or rule in words, and then express the pattern symbolically. So let's talk about what that means. If you look at the coordinates, what I'm seeing is that the x coordinates always staying the same, but the y coordinates changing. So when I'm translating up, the x coordinates will remain the same. The y coordinates are all increasing by 2. So going from 3 to 5, I increase by 2. From 2 to 4, I increase by 2, and so on. So in words, I could write a verbal explanation and say the x-coordinate remains the same, but the y-coordinate increases by 2. We're going to focus primarily on coordinate rules, and the coordinate rule, the way to say that is you start with your x comma y, and you transform that to what the new coordinates are. So to show that x remains the same, I keep an x here, that does not change, but to show that we increase y by 2, an expression to say that would be y plus 2. Now I want to consider some other transformations as well, translations. So if I were to translate down 1 unit, translating down 1, this was a -3 originally, and this was a 4. And so what happens when I translate down is that the x-coordinates remain the same, so those still don't change, but the y-coordinates now decrease by 1. They are decreasing by 1 each time. So if I go to make a coordinate rule this time, looking back here, to make a coordinate rule for this one, we would have x, y will go to, well, the x still remains the same, but now the y coordinates, if I'm translating down, will be y minus 1. So whatever the original y coordinate is, but subtract 1. Well, what about translating left and right? If we look at this, and again, this was a mistake, a typo there. If I translate to the left and I look at the coordinates, and I'm trying to write a coordinate rule, what I see is here, now the x coordinates are changing, the y coordinates remain the same. So we have x comma y goes to, the y coordinate remains the same, the x coordinate is what's changing. And how it's changing is, if it was originally 0, we decrease by 3, -2, we decrease by 3, so each time we are decreasing by 3. So to show that, we would have x minus 3. So let's summarize this in our notes. Looking at this, first in the summary, I want to summarize that a translation is an isometry. That is an important part. Translation preserves side length and angle measure. To translate up 2 units, our coordinate rule was x, y, transformed to x comma y plus 2. When we translated down, we were x, y was transformed to x comma y minus 1. To translate left 3, we said it was x, y was translated to x minus 3 comma y. The y remained the same. And so now I want you to think through, well, what do you think the coordinate rule would be for translating right 4 units? Pause the video and then test your answer. In order to translate to the right 4, we're not translating up or down, so the y coordinate will remain the same. the x-coordinate will change. And to translate to the right 4, we'll have to increase that x-coordinate by 4. So that'd be x plus 4, comma, y. On your own, I want to see, can you figure out what the coordinate rule would be if I translate down 7 and right 6? So now I'm translating two things at once. Pause the video, try it on your own, and then check your answer here. To translate down 7, I know translating up or down impacts the y-coordinate. So I'm going to go over here and say y minus 7. To translate right 6, I know going left or right impacts the x-coordinate. So that is translating it. Right 6 would change the x-coordinate by increasing it by 6. So that would be our coordinate rule here. So all of these are called coordinate rules. On the next video, we'll talk about reflections.